Video recording of initial experiments in a subway car in acceleration and deceleration mode. The main task of the experiments is to accelerate and decelerate the experimental device, interferometer, and observe the interference pattern. According to preliminary theoretical calculations, during acceleration or deceleration, we should observe the displacement of interference fringes, Doppler frequency shift. We should notice that interference noise in the subway car is less than anywhere else, so we can notice with the naked eye the displacement of interference fringes in acceleration or deceleration mode.
Станция Нижегородская, платформа слева. Выход к железнодорожной платформе Карачаево. Следующая станция Новокотловская, платформа слева. This is Нижегородская. The next station is Новокотловская.
Ну, женщина дома. Напугались его, да?
Ну, еще нет, конечно. Ну, интересно.
Нет, знаете, что это такое? Прибор. Это очень трудно объяснить. Я думаю, что если у вас нет образования, то вы вряд ли поймете. Физическое. Это надо писать научно-популярную статью.
Все равно самое сложное вещи, когда мы снится,
Не все. А в конце, когда доедете, да, вы одновременно должны нажать здесь и там, чтобы я мог совместить.
Станция Новокотловская, платформа слева. This is Новокотловская. Станция Новокотловская, платформа слева. Следующая станция Угрешская, платформа слева. This is Новокотловская. The next station is Угрешская.
Здесь это наш, да?
Станция Угрешская, платформа слева. This is Угрешская. Станция Угрешская, платформа слева. Следующая станция Дубровка, платформа слева. Наземный переход на станцию метро Дубровка. This is Угрешская. The next station is Dubrovka. Change for Dubrovka metro station.
Так, разгон хорошо лезет. Если разгон идет, сползает, да. Так, и при торможении чуть ослабится. Ну, в общем, пока непонятно. Это скорость. Здесь 60 данных, да?
Станция Дубровка, платформа слева. Наземный переход на станцию метро Дубровка. This is Dubrovka. Change for Dubrovka metro station.
Summary. Preliminary theoretical calculations are correct. During acceleration or deceleration of the experimental device, interferometer, in the subway car, the displacement of interference fringes, Doppler frequency shift, can be noticed with the naked eye. The next episode is a video recording of the initial experiments in the car in acceleration and deceleration mode. The main task of the experiments is to accelerate and decelerate the experimental device, interferometer, and observe the interference pattern. According to preliminary theoretical calculations, during acceleration or deceleration, we should observe the displacement of interference fringes, Doppler frequency shift. As it turned out, the interference noise in the car is quite large. Since when moving by car on the road, there are stronger vibrations. Therefore, it was difficult to observe with the naked eye the displacement of interference fringes in acceleration or deceleration mode. Accordingly, the resulting signal was processed using the lock-in amplification method in order to isolate the useful signal from the total interference noise. The graphs show a clear correlation of the useful signal in the form of the displacement of interference fringes, Doppler frequency shift, during acceleration or deceleration when moving by car. The next episode is a video recording of initial experiments in a 4-seat fully aerobatic utility airplane in acceleration and deceleration mode. The main task of the experiment is to accelerate and decelerate the experimental device, interferometer, and observe the interference pattern. According to preliminary theoretical calculations, during acceleration or deceleration, we should observe the displacement of interference fringes, Doppler frequency shift. Summary. As it turned out, The interference noise during flight on a small 4-seat airplane was the highest due to the fact that there were very strong vibrations from the airplane engine. Therefore, it was difficult to observe with the naked eye the displacement of interference fringes in acceleration or deceleration mode. At the moment, we can say that the results of the initial experiments are positive and correspond to our preliminary theoretical calculations. When we moving with experimental device in different vehicles in acceleration or deceleration mode, we register a useful signal in the form of the displacement of interference fringes, Doppler frequency shift. In a subway car, due to low vibrations and deformations, we can observe the displacement of interference fringes with the naked eye. In other cases, it is necessary to filter the useful signal from interference noise and other parasitic effects. In order to minimize the number of negative factors, we need to move to the next stage of R&D, key experiments with a new, more advanced type of interferometers in a state of free fall, microgravity, on an airplane. Gravitational acceleration of 9.8 meters per second squared will allow us to clearly and with minimal noise register the useful signal in the form of a clear, smooth and uniform displacement of the interference fringes, Doppler frequency shift, and identify all problems when registering the useful signal.